11.3, determining probabilities using fractions. Working example number 1. Calculating probabilities using a table and multiplication. So, first example here, Mackenzie spins a spinner and rolls a four-sided die. So the spinner has yellow, red, and blue, and the four-sided die looks like a pyramid, and it's got the numbers 1, 2, 3, and 4 on it. Complete the table to show the sample space. And the question is, how many possible outcomes are there? So we've got the spinner, blue, red, and yellow. And then the die, 1, 2, 3, 4, to create our table. Color comes first from the spinner. So then we've got red is first all the way across here. And then yellow is first all the way across here. And then 1 goes all the way down. Then 2. And 3. And 4. So that's the chart done with the table. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 possible outcomes based on this table. Part B. What is the probability of spinning B and rolling a 2? Right answer is a fraction. Well, to do that, fraction is favorable outcomes over top of possible outcomes. So B2, all the B's are across here, so it won't be in one of these bottom ones. B2 is just this option right here. It only appears once in this table. So our favorable outcome there is 1. Possible outcomes we already said was 12, so that's the bottom of our fraction. So the probability of spinning blue and rolling a 2 is 1 out of 12. Now we could convert that to a decimal, we could convert that to a percent, but right here it's asking us to put it as a fraction. So remember, reading your question is important. You have to know what it is you're looking for, what information you're needing to present back as an answer. So part C, use multiplication to find the probability of blue and rolling a 2. So to do that, find each probability separately. The number of blue sections. So the probability of calculating blue, well, on that spinner, there is 1 blue section out of 3. So the probability of rolling a blue out of the total number of spinner sections is 1/3. Now, probability of rolling a 2, there's 4 numbers on the four-sided die, and the 2 is only one of them. So there's 1 out of 4 possibilities there. And as we said, it was 1 out of 3 for the probability of blue. If you multiply both of these individual possibilities together, 1 times 1 is 1, 3 times 4 is 12. So you can take each individual one to figure out the combined. You don't necessarily have to use your table to do that. Okay, and then this is 1 out of 4 over here. I should draw a line here. Let's turn the page. Part D, using the information in the table. Same example still. What is the possibility of red or blue and 4? Well, from the table, red or blue is the top 2 lines, and a 4 appears twice. So 2 possibilities that are favorable out of a possible 12. So our new probability is 2 out of 12 for this case. We can use multiplication to check our answer. Blue and red are our favorable outcomes. Well, on the spinner, we've got red and blue. That's 2 of the 3 possibilities. And the other part of the question was rolling a 4. Well, there's only 1 4, so there's 1 out of 4 possibilities for rolling the 4. If you multiply those 2 together, 2/3 times 1/4, 2 times 1 is 2, 3 times 4 is 12. you get the same answer as what the table provided, 2 out of 12. So let's try another example. Working example number 2, calculating probabilities using a tree diagram and multiplication. So Jason rolls a 4-sided die and spins a spinner. What is the probability of rolling an even number and spinning a bee? Show your answer using a tree diagram and multiplication. Well, let's finish the tree diagram. The die has 4 possibilities, so 1, 2, 3, and 4. And the spinner had 3, A, B, and C. So A, B, C, A, B, C, A, B, C, and A, B, C. 1A, 1B, 1C. 2A, 2B, 2C, 3A, 3B, 3C. And finish it like that. Make sure you throw in your commas to separate the 2 different events. Alright, so what is the probability of rolling an even number and spinning a bee? So look for the B's. 1 is odd, so that one doesn't count. 2 and B counts. 3 and B doesn't. 4 and B does. So there are 2 favorable outcomes out of a total of 12 outcomes. So then that means that the probability of an even number and B is 2 out of 12. So that's using the tree diagram. We've done a table to find our information as well. But we can shortcut it, and rather than having to write out all this information, we can break this down and look at each experiment individually. So the probability of rolling an even number, 1, 2, 3, and 4. 2 and 4 are both even, so there's 2 favorable outcomes out of a possible 4 when you're rolling a die to get an even number. The probability of spinning a bee, when you've got A, B, and C as your sections, there's only 1 B out of 3, so your probability there is 1/3. Multiply both of those fractions together, 2/4 times 1/3, and then you're left with 2 times 1 is 2, 4 times 3 is 12. So again, same solution here and here, but this requires a lot less writing to get to your answer. The tree diagram is good to visualize your sample space and see exactly what the possibilities are. But if all you need is to do the calculation, this is a much more efficient way to do it. Alright, next up is a show you know. So it's your opportunity to practice this new skill and see what you can do. Please go ahead.